Hello, today we're presenting our math project. Along this partial, we talked about trigonometric identities. We saw that sine squared plus cosine squared equals a 1, that 1 plus tangent squared equals secant squared, and that 1 plus cotangent squared equals cosecant squared. However, we thought about what are the true uses of these identities in the real world. We didn't know, and we had to investigate about a sport that uses these identities, a mechanical use to do these identities, and other uses of these identities. So, my partners Gerardo, Ali, and Emiliano are going to present a little bit of these uses and how we can use and turn this knowledge into something of use. Thank you.
I will talk about the Fourier series. The Fourier series is an infinite series that has a stable point of convergence. The utility of this series is that using it, you can simplify more complex periodic functions into smaller and simpler functions such as cosine and sine with integer numbers, make it easy to calculate some big equations. You can use it to calculate the electric tension, to analyze the behavior of an harmonic wave or sine, the study of the sounds, how it behaves, the waves of it. You can reinforce signals of any kind. For example, you can, using this, an emitter with this sign, you can increase the power of a radio sign, internet sign, Bluetooth, anything. Also, you can solve many equations with it of many areas. It could be mathematics, physics, chemistry, such as the head transmission and the theory of the shells. You can see it on the graphic that you can match this Fourier using its central equation. So that's the way you can make it work. It also doesn't need to be linear. You can use it in diagonal or make it behave in many different ways. It's very important to make a point on this, that it's not only useful for mathematics or for engineering, it's useful in many areas and you can give it a lot of functionality.
Hi, in nature the trigonometric functions are used almost anywhere. We know that the light and the colors can be measured by waves, and also the sound can be measured by waves. The water waves behavior can be measured by trigonometry. I want to explain a very important task of the trigonometric functions, the Richter magnitude scale. This measurement is used for determining the force and movement of the tectonic faces. A scale from 0 to 10, and a lot of machines, including a graphic one, is used to determine the force of an earthquake. This measurement was developed by Charles Francis Richter, and nowadays many countries use it for saving the lives of thousands and millions of people.
Sinusoidal graphs in Herbit. Sinusoidal graphs are graphs with successive waves or curves. They are sine graphs. The sinusoidal graphs are used to measure the heart rate, breathing rate, lung capacity, and blood pressure, but we are only going to focus in the heart rate. The sinusoidal sine waves in a heartbeat are created from the high frequency sound waves. The frequency is the amount of completed circles per second. The amplitude is the maximum distance from 0, which is always 1 on a sine graph, and the minimum distance from 0, which is always -1 on a sine graph. The period is the time it takes to complete one circle. Is a graph of sine because its constant wave or oscillation is repeated every 360 degrees.
I hope you find these uses useful, and I hope you can turn this knowledge into something good in your life. With this knowledge, we have finished our second partial project, and see you in the next partial project. Thank you.